All right, let's get started. Thanks for taking interest in our technical workshop in Esri Dev Summit 2020. My name is Jay Zhang. I'm a product engineer from Relan's development raster team. Today, our topic is how do you manage and sharing raster data for analysis. Now, a lot of users nowadays are utilizing ArcGIS as an imagery platform to work with imagery data. Imagery data from single raster to a large collection. Now, the purpose of our workshop today is to introduce a series of best practice or workflows to manage and sharing raster data for analysis by your client, by your users, by data scientists. Now, this is what we expect in this workshop, and I'm going to go through a high-level overview of what raster data support is in ArcGIS. And I'm also going to go through different data models and APIs we use to manage raster data in ArcGIS. And I'm going to introduce some common workflows starting from managing and sharing a single raster in ArcGIS to sharing a collection of raster in ArcGIS, or whether you can convert a raster data to optimized format to achieve a better performance utilizing a special format called the cloud raster format. And also, we also hear from our users there's demand that you want to keep your shared raster data up to date without actually interrupting your services. We're also going to introduce a workflow on how to do that. And last, we're going to briefly introduce the analysis capability on ArcGIS server to perform raster analysis in scale. Now, first of all, let me just give you a quick overview of what type of raster and imagery data support we have in ArcGIS. ArcGIS image platform provide a powerful system of record functionality. What that means is we support imagery data or raster data that was captured by all these different type of sensors. We support over 100 different raster formats, and they can be captured by a LiDAR sensor, can be a multispectral image, panchromatic image, or it can even be some scientific data set that is in the format of NetCDF, GRIB, HTF, and has data that across different dimensions. There's also drone imagery that we support and LiDAR image that we support. You can bring all this different type of raster data into ArcGIS, and in all these different ArcGIS apps, such as desktop apps, web apps, and ArcGIS server, we support the entire workflow of managing data to analysis, to visualization. Now, there are two very important data model or information model that we define in ArcGIS to help you manage raster data. There is this raster dataset, which basically represent a single imagery or raster dataset. What that means is you can have a single TIFF imagery. When you bring it into ArcGIS, it will be recognized as a single raster dataset. And the other very important data model is what we call the Mosaic dataset. Mosaic dataset is a powerful tool that lives in a geodatabase, either a file database or enterprise database, for you to manage a collection of imagery. The collection of imagery can be a spatial aggregated collection of raster datasets, or a collection of a raster data set that is completely overlap on each other but take home different times. Mosaic dataset, once you add all this collection of imagery to the Mosaic dataset provide a ability to dynamically mosaic your imagery collection together to create this seamless view of a single raster. And Mosaic dataset also provides you a table of records where you can see all the rasters that is managed by your Mosaic dataset. And essentially, you can treat the entire Mosaic dataset as a single raster dataset. And the other important enhancement that we want to emphasize today is raster can also be multidimensional. In Pro 2.5, we introduced this two multidimensional dataset that is available, that is a dataset that has spatial, temporal, and vertical dimensions. The multidimensional raster that can contain one or multiple variables in one file. A variable is basically a cube or cubes. A variable can be a time, can has time or a depth dimension, right? And each slice of a cube is basically a 2D array. It's a 2D raster. And when we're saying that a raster is a multidimensional raster, it can actually be coming from a Mosaic dataset or a single raster dataset. Now, what are the different tools you can use to automate your management and sharing workflows? There are two sets of ArcGIS, there are two sets of Python APIs in ArcGIS that can be utilized to support managing and sharing workflow. There is ArcGIS API for Python, which is designed specifically to work with ArcGIS Enterprise and ArcGIS Online. When utilizing ArcGIS API for Python, you perform your processing analysis remotely. Basically, it's a thin client wrapper that sends requests to the ArcGIS server, and all the analysis and processing will be performed on the server. And through this link, you can find more details about ArcGIS API for Python. And on the other side, we also have ArcPy. Now, many of you may already be familiar with ArcPy API. In order to use ArcPy API, you will require to have the desktop apps, such as ArcGIS Pro or ArcMap. Or the ArcPy is also available through hosted notebook servers advanced runtime. We're using ArcPy to perform data management and sharing workflows. The operation, the workflow, is actually happening locally. It's actually happening on the machine where you invoke or utilize your ArcPy API. Now, it's very important to recognize the difference between these two sets of API. If you want to know more about the ArcPy API, please go ahead and follow this link to learn more. And in this workshop, we're going to focus on utilizing the ArcPy to create and automate data management workflow and sharing workflow. Now let's go through different data management scenarios. Let's go through the first data management scenario, which is the simplest case, sharing a single raster. Sharing a single raster is actually pretty straightforward. We support ArcGIS server supports sharing all supported raster format. There's over 100 different raster format as to be shared as an image service. Sharing single raster dataset actually does not require the image server extension license. If you have server advanced license, you can also share a single raster as image service. Now, there are several places you can share a single raster. You can either share from ArcGIS Pro image service publishing wizard through the UI, or starting from ArcGIS Server 10.7, you can also share rasters through the ArcGIS portal create image layer user experience. I'm going to show demos about all these options. And the sharing, if you want to automate your sharing workflow, you can also utilize ArcGIS Server Admin REST API. Now, we're also currently enhancing the ArcPy sharing API to share image service. This is currently not available in the current release of ArcPy in ArcGIS Pro 2.5. The basic purpose of enhancing the sharing API is to make it simpler for you to share a single raster. And we are sharing sharing image service. We are sharing rasters to ArcGIS server. There could be two cases. One case is you actually want to upload your local raster dataset to a hosted data store. This is what we call the by value publishing mode. or you can also share the folder or share the data location where your raster is to the enterprise, and so that your data will not be copied to the server, and the image service will simply reference the data in the shared location. Okay, let me just show you the demos how you can automate the sharing workflow for a single raster. Going into Pro. Now in ArcGIS Pro, sharing a single raster using the UI is really simple. Now you have to make sure you are in the catalog view of ArcGIS Pro. Browse into the location where you have your raster data. Right-click on the raster data, click on Share as Web Imagery, and this wizard will pop out and have this. You have to fill in the service name, give a summary, give a tag, and as I mentioned earlier, there are actually two modes of publishing an image service. One way is you want to copy all your local data set, upload all your local data set to the ArcGIS server, and publish the service by value. Or the other mode is you can reference the data if you already register your data location to the ArcGIS server. And when you go into this sharing publishing wizard, the server and folder will automatically populate based on what ArcGIS portal that you sign into within within ArcGIS Pro. If you have more than one federated server is ArcGIS portal, please make sure you choose the appropriate server that you want to publish image server to. And it is always a good habit to click on Analysis button to make sure and detect any issues or errors that you may have while publishing your image service. Now, in this warning message, basically tells you that your data source is not registered with server, and data will actually be copied to the server. By double-click on the warning, you can actually it will actually pop out a dialog for you to resolve this issue. Now, this is how you publish a single raster through UI within Pro. You can also go into the portal publishing user experience. And if you, starting from ArcGIS Server 10.7.1, if your ArcGIS portal has a federated image server configured, you can go under your content page and go into the Create, click on the Create button, and you will have this image layer option. Click on the image layer option, it will pop up this user experience for you to create a imagery layer. There are 4 different modes that you can choose to create image layer. You can either create one single image, you can create an image mosaic from a collection of imagery by mosaicing all of them together into one single raster dataset, or you can create image collection. What that means is basically you can ask the server to create a mosaic dataset behind the scene that references a collection of imagery. Or if you want one single layer for each image you upload, you can choose to publish multiple image layer option to publish multiple layers. If I just want to create one image, I choose the first mode and I click Next. And this user experience on Portal also provides you the option to either upload the dataset from local folder, or you can browse into a data store that is already registered on the server and choose the data that you want to publish by reference. And then just click Next and give the title and tag. Now, because time constraint, I'm not going to create this layer. So, and then the next is just to create the layer to publish the image service, right? So the key workflow I want to show you is how do you automate all this by using Python. As I mentioned earlier, as of a current release, the ArcGIS sharing API does not support sharing image service yet. Therefore, we'll be utilizing ArcGIS Image Server REST Admin API to publish service. We'll be using the request module that is available in Python to make a REST request. And the first step to share a single raster with ArcGIS Image Server is to generate a server token, the server admin token. Right? There are two possible cases where you can generate a token. One case is if your ArcGIS server is federated with Portal. Because the ArcGIS server's security is being taken over by the Portal authentication, therefore you need to create a ArcGIS Portal token. And if you're working on a standalone ArcGIS server, then you'll be using the ArcGIS server's generate token API. So generate token REST API is as simple as using either the Portal sharing URL or the server admin URL, and use the generate token call by providing the username and password and all other settings such as expiration date and referral to create a token. In this particular case, I'm generating a admin token on a server that is federated with ArcGIS Portal. So in this case, I'll be using the ArcGIS Portal sharing API and use my ArcGIS federated server URL as the referral. And once the admin token has been generated, now the next step is to actually start configure image service and publish to the server. Now all the image service essentially is defined by this JSON object. You can learn more about this JSON object that defines image service by looking at the image service that is already published on, through other means on your ArcGIS server. Now there are a few key properties I want to emphasize on this JSON configuration of image server. First of all, you have to define the name for the image service. Obviously, the name has to be unique. It cannot be a name of the service that is already exists on your server. And there's capabilities you can define for the image server. You can define whether the client can access the pixel data, metadata, or perform measurement on the image service. And also, you need to define where the source data is for the image service through this path properties. So basically, in this particular image service configuration, my image service is published from this DEM TIFF imagery that is under this folder. And once you have the image service JSON defined, the next thing to consider is how you want to publish data. As I mentioned earlier, if you want to publish your image data by value, you will be uploading your raster data to a hosted location of ArcGIS server. Or it is generally recommended to publish image service by reference. In order to do that through Python, you have to first register a data store to the ArcGIS server. The way to register a data store is using the ArcGIS server's data store register item API. Make sure you use the server admin URL. And the data store item can be defined using this JSON object. Basically, you need to define unique path for the data store item and also specify the folder location and specify the type of the data store and the location, the actual path of the folder that you want to register to the server. And then just send the REST request to the server to register the data store. Once the data store is registered, you can finally use the server's create service REST API to create a service. Now, if you want to create a service in a particular folder, you can also give a folder name after the service. After the service path. And so basically, you just need to use the token we generated earlier, and also the JSON definition of an image service, and then just send a post request to create a service. Once the service is created, can make a connection to ArcGIS portal and find the service that you shared and display it here. So this is the way how you can automate the entire publishing workflow using Python to publish a single raster to image server. Now the next scenario I want to talk about is how to manage your data using Mosaic datasets. Now, as I mentioned earlier, Mosaic dataset is actually a really powerful tool to manage a collection of imagery. In order to manage a collection of imagery through a Mosaic dataset, we have to introduce this concept of raster type. As I mentioned in this overview, we support over 100 different raster formats and 30 different raster types that was captured by all these different types of sensors. The raster type is basically something that identifies metadata of a type of raster data. For example, Sentinel-2. You have to use appropriate raster types in order to add a particular type of data into the Mosaic dataset. The other powerful ability that raster type provide is it also can define a on-the-fly processing template that you can implement on the raw raster data and then combine with the data and then add it into the Mosaic dataset. What that means is basically if you have raw panchromatic data or multi-spectrum data, and by defining a pan-sharpen processing template, you can dynamically create a pan-sharpen raster dataset within the Mosaic dataset. Now we have over 70 different raster types that covers different type of sensors, including satellite sensor, UAV, aerial, scan, scientific data, radar, LiDAR, or even GIS services. And you have to choose the appropriate raster types to add raster to Mosaic dataset. And the raster type is also extendable with Python. Now, this is not the focus of this workshop, but I do want to mention that if you find a new type of sensor or new type of data that is not covered by the existing raster type that we have in ArcGIS, you can use Python to write a custom raster type. Right? You can search more about custom raster types in our online help, but this is not the focus of our today's workshop. The other important factor you want to remember is the raster data that you manage through Mosaic dataset is reference. It's not copied to the Mosaic dataset. We have over 32 different tools to work with Mosaic dataset, starting from creation. There's create Mosaic dataset tool, and add raster to Mosaic dataset tools. And there's modifications, tools used for modifications. You can build footprints on the raster items in the Mosaic dataset. You also define no data. There's also enhancement, where you can build sim lines and color balance all the rasters in the Mosaic dataset. And you can also, since Mosaic dataset provides you this tabled view of all the data, you can also use additional ArcPy API like Data Access Cursor API to work with the table view of the Mosaic dataset. Now, sharing Mosaic dataset is similar to sharing a single raster dataset. The difference is it actually requires the image server extension. Again, you can share the ArcGIS Pro, share the Mosaic dataset from ArcGIS Pro image service publishing wizard. You can also share Mosaic dataset through ArcGIS portal, create image layer experience. And you can, and today we're going to, through the demo, we're going to talk about how you can automate sharing Mosaic dataset workflows and managing Mosaic dataset workflows using ArcGIS Python API. And the other things that you want to remember is if you share if you share a Mosaic dataset as image service, the image server, if it is the sharing mode by reference, the image server will need access to both the location of the Mosaic dataset and also the raster data that the Mosaic dataset is referenced to. Okay. Now let's look at the second demo and see how we can automate the Mosaic dataset management and sharing workflow in Python. Now in the second demo, I'm going to create a Mosaic dataset using the NDFD, the National Digital Forecast data that I download from NOAA. So this dataset is a weather forecast dataset that basically predicts the temperature change in the upcoming 4 days. So I simply grab a Bing file from their FTP site, which has the prediction of temperature from March 12th to March 16th to March 20th. So I'm going to use my Mosaic dataset to manage this weather raster data. So first of all, just importing all this necessary modules we're going to use in this demo. And remember that Mosaic dataset lives in a geodatabase. So that you should create your Mosaic dataset in a geodatabase. You have the option to either create your Mosaic dataset in a file database by creating a file database and then call the create Mosaic dataset. Or you can create your Mosaic dataset and manage your Mosaic dataset in an enterprise database. Now the reason why you may want to choose the enterprise database, I'll cover later. In order to create a Mosaic dataset, you have to define a name and also a spatial reference. This is basically a spatial reference of the data that I will later be added to the Mosaic dataset. Now by creating this Mosaic dataset, let me just run this. Now for creating the Mosaic dataset in an enterprise database, you have to first create an enterprise database connection by defining a location where you want to store this connection file. You need to give the server name of your enterprise database, give the username and password, and the rest is the same. You just use the create Mosaic dataset dual processing tools that is available through ArcGIS API to create a Mosaic dataset. Now, let me just run this. And once the Mosaic dataset is created, it's just an empty table now that exists in your geodatabase. The next step is to actually add raster to the Mosaic dataset. So I'm defining the location where my data is. And I have to choose the appropriate raster type, which is the grid raster type. A grid raster type recognizes the NDFD dataset that I download from NOAA. And there's also additional settings you can configure for the raster type through the auxiliary options. For example, in this particular case, I'll be just adding the temperature variable from this more dimensional weather dataset. And the first create Mosaic dataset is still running. And the next thing is, as I mentioned earlier, because your Mosaic dataset is also a table that exists in the database, you can also use the ArcGIS data access cursor to access the table view and customize the table of Mosaic dataset. In this particular example, I want to compute stats. I want to compute statistics for all the raster items in the Mosaic dataset. And then after that, I want to create a new field called regional average temperature for my image collection. And I can simply use the add field tool to add a new field to the Mosaic dataset. And then later on, what I'm doing here is essentially create a search cursor that goes through every raster items in the Mosaic dataset, read the raster dataset from it, and then use the getRaster property to get the mean temperature for the entire region, and then convert it to Fahrenheit, because the temperature recorded in the Mosaic dataset is Kelvin. And then I'll compute the average temperature for the entire region and then update the table with the new value. And then after I have done that, I have finished configuring my Mosaic dataset. I'm following the same routine as I showed in my last demo to use the admin API to generate token, define my image service, and then share my image service. Now, if you look at the Mosaic dataset that I created through this workflow, it appeared to be freezing here. Okay, let me rerun this. I believe if I have another backup here. Okay, let me just let the demo run. And we'll come back to view the result later on. Okay, let's move on. Okay, this is the second demo in our managing and sharing raster data for analysis technical workshop. Now, in this particular example, I'll show you how to use Python to automate the process of creating Mosaic datasets and sharing Mosaic datasets in service to your ArcGIS server. Now, as I described earlier, Mosaic dataset is a very important information model to manage a collection of rasters. In this example, what I'm going to do is I'll be creating a Mosaic dataset in a file geodatabase, providing you several options where you can create your Mosaic dataset, and then add the national digital forecast data that I download from NOAA into this Mosaic dataset. Right, so first of all, you need to import all these modules you're going to use. And this time we'll be using the ArcPy API instead of just the request API. Request API is used to publish the image service. ArcPy contains all the tools we need to create and configure the Mosaic dataset. The next step is to actually create a geodatabase that can host our Mosaic dataset. In this particular example, I'm creating a file geodatabase for my Mosaic dataset. Alternatively, you can also use the existing enterprise database to create and host the Mosaic dataset. Now, if you are creating the file geodatabase, simply using the create file GDB tool, and then use the create Mosaic dataset tool. When you are creating Mosaic dataset, you have to define a name and a spatial reference. And if you're creating a Mosaic dataset in the enterprise database, you have to create a database connection file first. The database connection file, enterprise database connection file, is a file that with the .sd extension. Simply use the create database connection tool, providing the location where you want the file to be, a name, the server name, the server type, username, password, and the database name. And the rest is the same. If you want to create Mosaic dataset in the enterprise database, providing the enterprise connection file as your workspace, and then define a Mosaic dataset name. Now that my Mosaic dataset has been created, it's just the empty dataset that we'll be adding raster data into. The next step is to add raster data to Mosaic dataset. So this raster data that I want to add is, as I said earlier, the National Digital Forecast dataset that is forecast data for the temperature in the Pacific West region. So this is the GRIB dataset, the bin file that I download from NOAA's FTP site. And I need to choose the appropriate raster type, which is the GRIB raster type, and then also providing additional options as of in this case. I'll be adding just the temperature variable from the GRIB dataset into my Mosaic dataset. Now this GRIB file is a specific type of multidimensional data. It actually has multiple layers that recording data captured at a different time frame. So you just use the add raster to Mosaic dataset tool to add this GRIB dataset, GRIB files into the Mosaic dataset using the GRIB raster type. And by turning on the estimate stats, you can see the data rendered better in the map. Now let me just execute this add. Let me see, execute this add. Wait for a while it's adding some forecast data into the Mosaic dataset. Well, the temperature forecast data that I download on the date of March the 12th this year actually contains forecast temperature from the date of March the 16th to March the 20th. Now, if you look at the Mosaic dataset, you can open the table and also switch to the map. You can see this is my NDFD dataset managed by Mosaic dataset, and we also expand the metadata information that we read from GRIB dataset and populate it as field values here. So the standard time basically, a standard time field basically record that different data slices that exist in this GRIB file. Basically, it indicates that this is the forecast data from March 16th to March 20th. Now remember that I mentioned earlier, you can, because Mosaic dataset also provides you this tabled view of the collection of raster data. So you can also utilize some other ArcGIS API that works with table to work with the Mosaic dataset. In this next step, what I want to do is I want to calculate statistics for each slice, each raster items in my Mosaic dataset to get status information such as min, max, mean. And then I want to add a new field to my Mosaic dataset table, which is the regional average temperature in the unit of Fahrenheit. So because Mosaic dataset is also a table, you can use the build pyramids and statistic tool to compute item statistic in the Mosaic dataset. And you can also use the add field tool to add a new field to the Mosaic dataset. And furthermore, we want to read every raster item in the table using the search cursor, the data access search cursor, and then using the get raster properties tool to read the mean pixel value of each raster. Essentially, the mean pixel value of each raster is the mean temperature of each raster, right? And because all the temperature values are recorded as Kelvin in the unit of Kelvin, so we need to apply a formula to convert it to Fahrenheit, right? So after you have done this, and the cursor that you use to update the Mosaic dataset table is the update cursor. Let me just simply run this command. Wait till it finish updating the cursor. The other thing that I'd like to mention here is the DA cursor, the data access cursor, supports reading raster items from the Mosaic dataset table, but it actually does not support updating the raster item. In order to update the Mosaic dataset, you have to specifically define the field you want to update. You cannot just simply say, I want to update the entire row, including the raster field. That will be ended up being a failure. Now that you have updated your table, if I go back and open up the attribute table, you can see a new field has been added, and it is actually the temperature of Fahrenheit. Regional temperature of Fahrenheit. Okay, now after you finish configuring your Mosaic dataset and add your data, next step is to share the image service. It's the same process as the first demo that I showed earlier. You need to generate a publishing token using the generate token API, providing the username and password. And you also need to define, let me just execute this. And you also need to define the image service definition for the Mosaic dataset. Now, one thing you need to pay attention to is, since now you are publishing a Mosaic dataset, there are additional properties that is different to publishing a single service, image service, a single raster image service. For example, the capability may contain a catalog capability, which means that you're actually allowing the client to access your Mosaic dataset table. Let's see if this one's done. Just execute this. And also, you want to define your pass property pointing to the Mosaic dataset. And the last step is just to invoke the create service API, REST API to create the service. Yeah, because this already exists. So let me just change the name here. And execute it again. Now the service has been published successfully. You can go into your portal contents and simply refresh the page. And you can see the new service published. Right, this image service will have the new field that you added, which is the average regional temperature in the Pacific West region. Okay, now this concludes our second demo. Basically, this demo shows you how do you automate the process of creating Mosaic datasets, add raster to the Mosaic dataset, and publish Mosaic dataset as image service. Now, the third data management scenario I want to talk about is how do you manage a cloud raster? Right, this is a very common workflow nowadays that a lot of our users are actually utilizing raster and storing their raster data in the cloud storage. Now, there are two ways ArcGIS provided you to access data in the cloud. From ArcGIS Pro, you can create something what we call the ArcGIS Cloud Store connection file, which make a connection to the cloud storage, cloud object storage that contains your raster data. The cloud object storage, the supported cloud object storage provider are Amazon AWS S3, Azure Object Storage, and Alibaba Object Storage. What that means is basically you can have your raster data that stores in all these different cloud providers, cloud object storage, and ArcGIS Pro can directly work with this data set, with this raster data set in the cloud. And when you are actually, there's a different route where you want to let ArcGIS Enterprise image server access data in the cloud storage. You're going to create a data store item similar as you saw in my first two demos, create a cloud data store item to access the cloud object store in all these different providers, for all these different providers. And when you are managing raster data in the cloud store, what we support is you can store, we are supporting reading of any supported raster format that you have in the cloud store. If you want to write raster to the cloud store, you can either use the transfer file geoprocessing tool. What this tool does is basically transfer the image files as is to the cloud store. If you want to transfer TIFF imagery, for example, to the cloud store, you can just use this transfer file. Or you can use the copy raster tool. You can convert the raster data to this new cloud raster format. I'll explain more about what this cloud raster format is later on. There's a reason why you want to convert your raster data to the cloud raster format in the cloud store. The Mosaic dataset can also reference cloud raster. The best practice to manage raster data in cloud store is if you want to perform analysis to the raster data in the cloud store, you have to bring your analysis close to the storage. What I mean by that is if you store your data in a certain region of, let's say, AWS S3 in US East, it is always the best practice to have your analysis application deploy on the machine that is near to the data store region. You have to deploy your VMs close to the AWS S3 storage at the US East region. And it is the reason why you want to convert, the other reason that you want to convert your cloud, want to convert the raster data to a particular cloud optimized format is to achieve a better read and write performance. For example, there's this cloud optimized GeoTIFF, which actually is designed specifically for the cloud storage to optimize the reading speed from the cloud store. And I'll talk more about cloud raster format. Why do you want to recommend you to convert your raster to the cloud raster format when you are managing data in the cloud store? Because cloud raster format is a specific type of format that we introduced in ArcGIS. It is basically a tiled raster dataset with a predefined tiling scheme. And because it's tiled, it is also a full-blown raster dataset with all its metadata information coming from the format that you convert it from. And because of this tiling structure, it is optimized for distributed analysis. We can parallelly read and write cloud raster format datasets. And when you are reading the cloud raster format from your local application, we also support local caching. What that means is ArcGIS Pro can pre-download those tiles from the cloud storage and speed up the read locally. And cloud raster format raster dataset is also optimized for fat web client. What that means is some client application, web application that implement using ArcGIS JavaScript API can support accelerated client processing and rendering if the raster it reads is a cloud raster format. And we also enhance the cloud raster format specifically for multidimensional raster. You can perform a transpose on the cloud raster format to achieve the optimal profiling operation. And it's also much faster when you are slicing individual layers from the multidimensional raster.
All right, this is the third demo in our Data Summit 2020, Managing and Sharing Raster Data for Analysis technical workshop. Now, in this particular example, I will show you how to use Python to automate the workflow of managing cloud raster data with Mosaic dataset. Right. switch to Pro and in this example notebook. So what am I going to do is I'll be making a cloud storage connection to a Amazon S3 object cloud storage that that I have my Landsat data sorted on. Right, as you probably remember earlier that ArcGIS support reading and writing raster data from CloudStor, and we also the Mosaic dataset managing data story also support the cloud object storage. Now the way you do it is first of all import this necessary module. The way you do it is to create a CloudStor connection, ArcGIS CloudStor connection file first, if you are to access those data within ArcGIS Pro or through API. Right. So in this particular code segment, I'm defining my CloudStor name as S3 Raster and the provider is Amazon. And I need to provide the access key and secret keys to create to make the CloudStor connection. And the bucket that I'm going to that my raster data was stored on is called dataset 2020. And if you log on to your S3 console, you can see that that's where I keep my cloud raster data. Now, after you create a cloud ArcGIS CloudStor connection file, it will have a extension .acs. Now, using a ArcGIS Cloud Storage connection file is very similar to as using a enterprise database connection file. You can construct a data path that using the .acs file path, and all this data and folder that you store under the bucket can be appended to the end of ACS file path. So after I made this connection, next step is to create a Mosaic dataset. I want to create a Mosaic dataset to manage all the Landsat data that I already have in my cloud storage bucket. I have created this Mosaic dataset earlier, and the next is to actually ingest data to the Mosaic dataset. And all you need to do is construct a path that points to the ACS file, and then append the folder name, the folder that contains your raster, Landsat raster data, into this path. So ACS path plus a folder, U70, and another subfolder, Landsat 7 ETM. And then because it's Landsat data, so you'll be using the Landsat 7 raster type. Always remember to choose the appropriate raster type to add data. And one thing to keep in mind is, although we support over 70 different raster type that allows you to manage data through ArcGIS from all these different data sources, but only a limited set of raster type is supporting reading data from the CloudStor. If you want to check with the help document in order to find out what are the supported raster types for the cloud raster data. And you can also add additional options. In this case, I'll add an additional option to just add the multi-spectrum product from the Landsat data. And the rest is quite simple. Use the Add Raster to Mosaic Dataset tool to add the cloud data into the Mosaic dataset. Now, as you can see here, once the data is being ingested into the Mosaic dataset, it's just like accessing the local dataset. And it's actually reading the Landsat scenes from my S3 bucket. Now, one thing to remember is if you're using the ACS connection file to add the data to your Mosaic dataset, although the ACS connection file contains the credentials to access your S3 bucket, but the Mosaic dataset itself actually does not store those credentials. Therefore, if you remember earlier, if you want to share this Mosaic dataset as image service, you have always need to grant permission to the ArcGIS server the access to your cloud storage. The way you do that is by registering a cloud store data store item. Now, it's similar to the first demo that I showed you earlier. And in order to register a data store item, you need to generate a token, server admin token, using the REST API. And then a cloud store data store item can be defined using this JSON syntax. And you can, as you can see here, you need to define unique path for your cloud store. You have to define the type as cloud store, and also you need to specify a provider. And all the credential information is stored in this connection string property. You have to give access key and the secret key. And also for Amazon S3, we also support IAM roles. And the object store property is used to define the bucket name. After you register your cloud store to the ArcGIS server, and then you can define your image service, and then create the service. So even though you create your Mosaic dataset, you ingest data using the ACS connection file, but you actually do not need to share the ACS connection file to the server. So all the accessibility, the data access is supported through registering this cloud store data store item. Let's take a look at the service that we created earlier. As we're adding the service to the map, as you may notice, it's actually taking a long time to render the service. The reason why that is because the server is actually pulling data. The server is actually installed on my local machine here in Redlands, but my Landsat data was actually stored in the Amazon S3 bucket, which is located in the US East. By pulling those raw TIFF files, which consist of the Landsat scenes, from a remote region to my local machine, it actually takes quite a long time. So what I would suggest earlier is that you can convert your data to this optimized cloud raster format. Now, converting a raster dataset or Mosaic dataset to a cloud raster format is also very simple. You can simply use the copy raster tool, give it an input, either a Mosaic dataset path or a raster dataset path, and define your output path using the ACS connection file path. So I'll be converting the entire Mosaic dataset to a single CRF raster dataset, and I'm going to call it Yosemite Landsat7.crf. Because, as I showed in my earlier slides, when you are actually writing data within ArcGIS Pro or through the API, through the ArcPy API to the cloud store, you can only write the CRF format. But if you want to upload your data to the cloud store as is, then you should consider using the transfer file tool. Now that I have already converted my Mosaic dataset to CRF earlier, and I can simply display that by browsing into my ACS connection files. Now, as you can see, because all this benefit I mentioned earlier about cloud raster format, it can be displayed really quickly because I already have CRF local cache that the ArcGIS Pro pulled down from the S3 bucket earlier, comparing to just pulling the data on demand pulling the raw data on demand from the image service that connects to the remote cloud bucket is actually much faster. So this is something to consider. If you are okay with converting your image collection to a single raster or single raster dataset whose format is not a CRF to a cloud raster format, you'll be able to achieve all this performance benefit, but sometimes you may losing some capabilities that your original dataset supports. For example, if you are converting the Mosaic dataset to a single CRF, it basically physically mosaicing all these image pieces together to form a single raster dataset. You will lose the ability to browse back into the raw image files and see the dynamic mosaicing of this raw data. But if you just have a single raster dataset, large raster dataset, and you want to convert it to a cloud raster format in a cloud bucket, then you won't be losing any metadata information. You won't be losing any property that is stored in your original raster dataset. Okay, that concludes my third demo.
Okay, let me just go through the code now of the third demo first. So in the third demo, I'm going to show you an automated Python workflow to manage and share a cloud raster. So as I said earlier, if you want to access data in the cloud storage, you need to create a cloud storage connection file. The cloud storage connection file can be created through this create cloud store connection file GP tool, which is also available through the ArcGIS API. Now, you need to provide a cloud storage name, file name, and you need to give a provider name, which is Amazon, and you need to give the access key and secret key, and also need to define a bucket that where your cloud store is located. In this particular case, I have some Landsat 7 data that is stored in my Esri bucket. So I want to add those imagery data. I want to access those image data in ArcGIS Pro and add them and manage them in the Mosaic datasets. So after I create this cloud storage connection file, the next step is to create a Mosaic dataset for the cloud raster. Again, I can create a file database that contains my Mosaic dataset that will be used to manage my Landsat data from Esri buckets, give it a projection, and then I'll use the add raster to Mosaic dataset tool to add the Landsat data to the Mosaic dataset. In this example, I'm choosing the Landsat 7 raster type, and I'm also defining a processing template that is multi-spectrum to just add the multi-spectrum data to the Mosaic dataset. Now, one thing to remember is not all the 70 raster types that support raster data in the cloud store. There's only a subset of all the raster data, all the raster type that supports cloud store. You may want to check the help before you start using those raster types. And once you have the Mosaic dataset created, next step is to register cloud store to the ArcGIS server. Now, similarly to register file share, you have to create token, and then defining a JSON for the cloud store. Right, for the cloud store data store item JSON, again, you need to provide a unique path. You need to provide a provider name, and also the connection string is defined like this for the cloud storage. You need to integrate all your access keys, secret keys in this entire JSON object, and also the object store property is the actual bucket name that you have on the cloud store, on your cloud storage. And after you register your Cloud Store, and you can define your image service. Now, in this particular example, since I'm publishing the Mosaic dataset, there's additional settings that I want to mention here that is specifically applied to the Mosaic dataset. If you look at the image service configuration capability property, you can see that I have added this catalog property here. Now, this is specific to the Mosaic dataset image service. What this means is basically when you publish your Mosaic dataset, you will allow client to access the catalog, i.e. the table view of the Mosaic dataset. And also, you want to specify the path property points to the Mosaic dataset. Okay, then after you define your image service and just create service, make a call to create service, and you will be publishing your Mosaic dataset as image service. Now, alternatively, as I mentioned earlier, you can also directly convert your raster to cloud raster format into the cloud object store. Now, in this example here, I'm just simply using the ACS connection file path plus a cloud raster format dataset name that I want to use for my output dataset, and simply just use the copy raster tool to convert my Mosaic dataset to a cloud raster format. Now, if you go back and see, once you have created the cloud storage connection file, and the connection file will have a extension called .acs. Right. And the other thing that I forgot to mention is the reason why you want to register Cloud Store is, as I mentioned, when you're publishing Mosaic dataset as image service, the Mosaic dataset, the image server, if the publishing mode is by reference, the image server will need to have access to both the Mosaic dataset in this geodatabase here, and also the raw data, the source data that the Mosaic dataset is referenced to. Now, since we're stuck at the second demo, let's see if I can simply show you, or not. Seems like entire app is stuck. Let me restart. Okay, let me restart the app. For some reason, it's stuck in here. And continue with the rest. Okay, let me try to restart the app and continue with our presentation. Right, just a heads up that all this demo that I showed today will be available later on for download. So don't worry about this recording here. Now let's just continue, right? So the last thing I want to mention is how do you live update your image service? Right, there's a lot of demand that coming from user to be able to live update once you share your raster dataset as a image service. There's demand to keep on updating the raster data when a new version of data comes in, or there's new data that captured after time that you want to append to the collection. Now, ArcGIS Image Server also provide a solution for you to do that. Now, what kind of raster data that we support live update after you share as image service? You can utilize Mosaic dataset. There are certain requirements in order for you to update Mosaic dataset once it's published as service. the Mosaic dataset must be created in the Enterprise Geodatabase, because only Enterprise Geodatabase support multiple users updating the table at the same time. And once you publish your Mosaic dataset, the other thing you want to pay attention to is that the Mosaic dataset table schema cannot be updated. What that means is all the table field that exist in your Mosaic dataset after you share as image service cannot be altered. You cannot add new field and you cannot delete the existing field. But what's being supported is that you can remove existing record and add new record in the table without actually stopping the service. And we are also working on enhancing the cloud raster format so that once you publish cloud raster format as image service, you can also appending new data into the cloud raster format, such as, for example, if you publish a multidimensional raster, cloud raster format as an image service, you can keep on appending new data that was captured at new time frame to the existing cloud raster format. This is not currently available in the 10.8 release, 10.8 release, but it will be coming soon. Now let's give a quick demo on how you can automate workflow to live update your image service. If I can successfully restart the app. Let me just kill this instance. Okay. Okay. Right, while it's loading, let's just finish the last session of the presentation and then go back to the demos. Now, the last thing I have to mention is after we talk about all these different workflows, you can share your raster data as image service. Now, the purpose of sharing your data through ArcGIS server is to be able to provide your data scientist or your client to perform analysis on those shared image or raster data. And ArcGIS server actually also provide a very strong analytic capabilities through ArcGIS server. Nowadays, in the current release, ArcGIS server desktop, both desktop apps and enterprise apps provide you all these different type of building analytic functionalities. You can either, if you find the function that you want to, analytic tools or methods or functions you want to use that is already exist in ArcGIS, you can just simply use those building functions. Or if you want to build your own custom analysis workflow, you can also use Python to extend beyond all these building functionalities to write your own custom algorithms. And if you are dealing with data in a very large scale, large volume or large size of rasters, you can also implement this ArcGIS Enterprise architecture to perform distributed raster analytic. Now, this diagram shows a simple overview of the architecture of a distributed raster analytic deployment of ArcGIS Enterprise. You have the ArcGIS portal as the front end that communicate with ArcGIS Pro and web app viewers. And you have all these different ArcGIS server that perform different roles and federated to ArcGIS portal. You have a hosting server that is used to store hosted feature data. And you have a raster analytics server that can potentially have many different server node to perform a large collection of imagery or raster analysis in parallel to utilizing all this multiple server nodes. And you can also share your results as an image service on the image hosting server. Now, we are not going to dig in too much details of distributed raster analytics. Please check on other sessions on how you can utilize ArcGIS Enterprise to perform distributed raster analytics. Now, the other related technical workshops you may be interested in this demo theater, in this Data Summit 2020 is ArcGIS API for Python. This will actually give you an in-depth view of distributed raster analytics and how do you use ArcGIS API for Python to perform analysis with the support of distributed raster analysis. You can also check out the advanced analysis of satellite imagery using Python. And you can also check out the session of advanced custom raster processing using Python. That session is basically talking about how you can utilize certain ArcGIS API to write custom algorithms instead of using the built-in functionalities.
All right, let's show the last demo in this managing and sharing raster data for analysis workshop. The last demo I'd like to show you is automated workflow using Python API to update the raster data that you already share as image service without interrupting the service. Now, in this particular example, I'm going to use the Python API, and what I'm going to do is I'm going to load all those modules that I'm going to use and use the ArcGIS Server REST admin API to publish the image service that is stored in an enterprise database first. You remember that the server requirements we mentioned in our earlier presentation, that in order to support live update, your Mosaic dataset have to be created in a enterprise geodatabase. And after I register enterprise database and with the connection string, and choose the appropriate type, which is eGDB, and then you can send the REST request to a registered data store item. So this way that the Mosaic dataset in the enterprise database will be published by reference. Once you have done that, and you should define your image service. One thing that you want to pay attention to is if your Mosaic dataset is shared from an enterprise geodatabase, the properties of the image service has to contain the connection string, which is the same connection string that you used in the data store registration. And also, the dataset is defined using this raster property. So I'm going to publish this NDFD, National Digital Forecast Dataset, Mosaic dataset, that contains 4 days of weather forecast from March 16th to March 20th. I'm going to publish this Mosaic dataset as image service, and this is my image service definition. And then same as last few demos, I'm going to use the create service API, send a post request to server using the token that I generated earlier to publish the service. Now, once the service is published, it looks like this. Let me just switch the map. Right. If you go ahead and open the attribute table of the service, you can see that it contains the forecast data from March 16th all the way to March 20th. Now imagine a scenario that because NOAA is updating their weather forecast data every day, right? Every day there's a new temperature.bing file being uploaded to the FTP site. And if I want to keep updating my service to deliver the most up-to-date forecast data, then you will have to keep on downloading the new data from the FTP site, removing the old record, from the Mosaic dataset and add new forecast data. Now the way to do that is very straightforward. So now that you have your image service published, because the Mosaic dataset behind the image service has all the requirements we need, right? It is stored in the enterprise database, and the new data that we are adding into the Mosaic dataset is the same type of data that will not alter the table schema of the Mosaic dataset, i.e., will not create or delete existing field. So all you need to do is remove the old record from the Mosaic dataset. As we know that the old forecast data has the forecast date from March 16th to March 20th. So I'm just removing all the old records from the Mosaic dataset using this time query. Anything that before March 21st will be removed from the Mosaic dataset. And you can use the newly downloaded temperature forecast file, the temp bin, which is what I downloaded on March 15th. This dataset will contain new forecast data. I believe it's from March 18th to March 22nd. So we'll see. Right, so all you need to do is removing old records and invoking the add raster to Mosaic dataset tool again using the appropriate raster type and specifying additional settings to specify the variables you want to add into Mosaic dataset as what we did earlier. And then just execute the tool. Remember, in this whole two-step process, the service itself is not being stopped. You can do this if you meet all the requirements that we mentioned earlier. Now that, because this two-step will actually take some time, so I'll show you the service that I have already updated earlier. Now, this Mosaic dataset published in service actually contains the new data that I downloaded on the 15th. As you can see, comparing with the old dataset, our new forecast data is starting from March the 18th all the way to March the 22nd. And because the old record is being removed, the object ID, the previous object ID is no longer visible in this table. And now the Mosaic dataset contains all the new data. Okay, that's it. That's all this demo I'd like to show you regarding how do you live update your image service. So all the Python example that I showed you today will be available for download later on. Please check back online and see if you can get this example, then run it by yourself. Thank you.
All this demo, all this notebook that I showed today will be available online for download afterwards. And please make sure that you check out all these demos later on. I'll make them available. And this is actually very useful workflows that you can utilize to automate your raster data management and analytic workflows and sharing workflows. Thank you very much, and hope to see you next time.